Hello again. So I'm going to solve that one. This example is very important. This example has got an idea. So I'm going to start with your idea. Then we are going to solve the example. Understood? So give me your idea. Here's the question. We have x square root of 2x plus 1 dx. Give me your idea. Even if it's wrong, it's okay. Yes? How? Just read it. How we organize it. So we see. Like that. Okay.
And then we will try to write the x as the derivative for the
Okay. So you mean 1 over 2, like that? What do you mean by that? Okay. I'll come to you. I'll come to your idea. Just be patient. That's your question.
Well, we write 1 over 2.
So I write what? You are not sure. So he organized it. She organized and she say maybe we have 2x plus 1 over 2x dx, and she's not sure. So I'm going to stop the first idea. I'm going to the second student. But actually, I like your idea. You say that one. Dx, right? As I predict, I say be patient. So he asked me the question. I said just be patient. Later you will answer. So what else? So what else? It's the idea. Third idea. Hello? Okay. Ladies and gentlemen, please give us one idea. We need it, eh? Yes? Okay, derivative of u. Which one is u? Just like, okay. So shall I write like that? For example, 2x plus 1 over 2x dx. And you say this one is u, that one is du, right? That's your idea. Good, thank you. That's a two good idea. So what else? Number 4. Hello? What was your name? Yeah. Okay, idea. How about you? Dear? Kak? Your name? Kak Abawski. Good. Give me more idea. I need it actually. Because I'm going to work on your idea. I see what's a problem, what's not a problem. No? Okay. We are going to discuss this idea one by one. Actually, we do like that, but it's not anything. Just at the first, just do it, good, but later I need after that one. So after that one, there is no idea. Why? Because she's stuck. She think about something that's not wrong, right? So that's why she's stuck here. So we say stuck. Stuck means she's stopped. You can say stop. Okay, here. Now, this idea, I like it because it's kafir. So it's taboo. You know why? Because if he didn't like that, you will do it at the exam. For example, if I give you, we'll go to the next page. If I give you sine of x, cosine of x, dx, you don't know how to control it. So he says easy peasy, sine dx, cosine dx, right? It's not true. It's not true, you know. So here's the point. Thank you. That's why I say, wait. No, for any function is not true. So not, we have not. First, let me write by green. F of x plus g of x dx with the integral. Or minus, both cases. You can write down like that, Kaka. You can write down, it's okay. Plus and minus, okay? For the second, but f of x multiplied g of x dx is not equal to fx dx dot gx dx. As we say, it's taboo. Forbidden, you cannot do it. Even with a division is not true, Kaka. You cannot use the division. Divisions, we mean quotient. Okay. You got it? So integral can, listen, integral can distribute over addition and subtraction, just. So you got it, right? And you got your idea, right? Thank you. Actually, it was good mistake. Some mistake is good, right? Teach you, make you to learn how to prevent it. So that's the second idea. That's why I say your idea, I need your idea. As a u du, Kaka. As a u du, derivative of here is equal to what? No. No, 2, you are right. Why you say no? It's 2, you are right. Okay, 2. Derivative of here, right here. Derivative of here, if u is equal to 2x plus 1, so you are right, du is equal to 2. Good. But what shall we do with that x? That's the problem. Yeah, that's why you stopped. You stuck. That's why I say you stuck, because you saw something is not good. So what we shall do, what we should do with that one, sorry. We have an x extra. You are right. If I remove this x, everything is okay. Right? We solved this one in the previous example. We just added 3 over 2 over 2 because we didn't have any x. But now we have extra. We have extra x. So u du is not working also. The idea was not working. Understood? So how we control it, how we solve it, that's the question. Now I'm going to answer. But listen, please, because you need, I want 100% of concentration, okay? You should be with me one step by step. At the beginning, I have x, okay, square root of 2x plus 1 dx. And we change that one. Actually, let me do it. We change that one to what? To, yes, as you say, 1 over 2. Any question for the first transformation? No. Listen, Kaka. Look, I'm going to say let you be the problem maker. Which one is the problem maker? The square root, right? The square root is the hardest things in this example. So I say let you be the problem maker. Was equal to 2x plus 1. So I'm going to change this one, all the x to u here. This example is with the x. I'm going to change it, transformed to u. By what? By letting u to be that one. Understood, dear? Any question? So how? Here's an example. And I want to change this one, and I want to change that one, and I want to change that one, all of them. So if u is equal to what? That one. So x is equal to what? Can you teach me? Tell me, sorry. X is equal to what? Because I want X, only X, huh? You can say 2x is equal to u minus 1. X is equal to what? Am I right? This one is first, that one be the second equation. Also, I wanna what? The example that I have. I want a dx, right? So I have x, I want to also change dx. So how I get dx? From the equation number 1. From equation number 1. U is equal to what? 2x plus 1. Du is equal to what? Am I right? Hello? So dx is equal to what? Just I want a dx. Du over 2. That one will be the third things that I need. Shall I repeat it? Yes, good. Here's your example. Am I right? We couldn't solve by any method that you mentioned. We cannot separate them, we cannot let them udu, right? We cannot do anything. So I'm going to just do like that. And I stopped. So we are, whenever you face such problem like that, try to use the let. Make the problem smaller. How? I say let here, what we have, let u, any variable that you like, ut, anything, be the problem. From here, try to get dx from here, from this equation. Try to get x, because this one's directly u1 over 2. Am I right? That one's directly u1 over 2. So that's why I'm going to get the x from this equation. How I get? I say 2x is equal to u minus 1. Am I right? Hello? So x is equal to what? U minus 1 over 2. Any question? And I'm going to get dx. How? I say u is equal to 2x plus 1. So from here, du is equal to what? 2 dx. But I want to just dx. So I'm going to say dx is equal to du over 2. And I'm going to recall that one as the number 3. Any question about 1, 2, 3? You got it now? Just from the first let. The first is very important. The other is the routines. Question, Jamaat. I'm not going to next step if you didn't understand, because actually we need to collect things. So it's your turn. Tell me, if I have x 2x plus 1 over 2 dx, can I change to something like that? Can I do like that? I say that one is by the second is u minus 1 over 2. Is it right? Hello? U is equal to that one, right? So can I change this one to u? This one for the girls, okay? Okay. Can I change that one to u1 over 2? Is it right? Hello? Yes. We let it be u. So u1 over 2. Am I right? Here's u. Okay, the next color. Can I change dx to that one? Can I change it or not? Yes. Why? Because we transformed all things to that equation, to the equation number 1. We use the equation number 1 to transform all these three together. Understood? Maybe you ask, why we change that one? Why? Because it's easier. than the previous one, and you can see. Now I have what? This is my problem now. I'm going to solve that one. Later, I'm going to change it to the x. So I say what? I say u minus 1 over 2, u to power 1 over 2, d to power 1 over 2. 1 over 2 multiply 1 over 2. Hello? 1 over 4. Am I right? U minus 1, u1 over 2, du. Now I'm going to multiply that one to inside. So I get what? ده يا جماعة ده u to power 3 over 2 minus u 1 over 2 du. Understood? The next step, do you understand anything? Hello? Question? No question. So just I multiplied. So 1 over 2 plus 1 will be 3 over 2. Okay. And I gave you note, the first note. We can separate or distribute integral over addition and subtraction, right? So we have a subtraction here. So I say is equal to 1 over 4. Okay, I'm a kana. U to power 3 over 2 du minus integral of u to power 1 over 2 du. Understood? No. We can for the first, we cannot for the second. Right? We see is equal. Means that we can do it. But that one you can. It's okay. You confused, okay. So you can do it. Anik, yes. No. Another good question. It's also a taboo. Yes, you cannot do it. He asked me, can we reduce or we subtract these? Can we subtract these together? That's the question, right? No. Let me give you some example later, okay? To solve that one, then later I'll come to your answer. Till here, any question? Good. Now, how we solve that one, please? Can you solve that one for me? It's easy. Yalla. Okay. The first one is equal to 5 over 2, thank you, u to power 5 over 2, 5 over 2, minus u to power 3 over 2, 3 over 2, plus c, right? Any question? Do you know why 5 over 2? Because there's u du, nothing else. So here's the solution. We got 1 over 4, 2 over 5, u5 over 2, 2 over 3, u3 over 2 plus c. And do not forget about, I gave you x, but you gave back u. We should what? We should change it, substitute again. So how we substituted? You know, in the previous one, we say u is equal to what? 2x plus 1. Do you remember that? The first example, the first question. So this integral will be 1 over 4, 2 over 5, 2x plus 1, 5 over 2. Understood? Minus 2 over 3, 2x plus 1, 3 over 2 plus. Any question? Any question, dear? Which du? You want to here, that one. If that one we have the integral. If I have anything, theta, du, anything, how's I get theta? 3 over 2 d theta. Anything, x, change it to the x, in your mind. It's just a symbol, x, x. How you solve that one? You see, you make it the beginning of the lecture. You see, make it that one to what? To the brackets. So derivative of x, dx. So I'm going to add 1 and divide by new exponent plus. You got it? So anything that you have, u, theta, theta, anything. Because the derivative exists, you can just solve it. Easy. It's not about what you have. It's about, we can solve it or not. Yes, we can solve it. Is equal to what? Is equal to this one, 5 over 2 over 5 over 2. Understood? Good. This is the first question. The second question that he mentioned, and we put on the red box here, I remember. So you see that why we are not going to say is equal to what, Kaka? It should be to what? Oh, okay. So you cannot subtract these together. But if this one, for example, if this one is 3 over 2, you can see is equal to 0. If I have 2, you can see is equal to 1 u3 over 2. Understood? If this one is 4, you can see is equal to minus 2u over that. You got it? Because you have a minus here. But if the exponents are different, we cannot do any subtract or anything. For multiplication is different. For multiplication is different. But for addition and subtraction, careful. For addition and subtraction, we cannot do anything. But if that one is, for example, division or subtraction, we see the base are equal. The base are equal. Then we are going to say is equal to what? 4 over 2. Because we say 3 over 2 plus 1 over 2. Did you understand here? What was the question? Because we have multiplication here. But here addition and subtraction, we cannot do anything. But here subtraction, multiplication or division, we can do something with it. Okay? Good. Then we can do it, yeah. We say that if they're equal, yes. Okay. That one we cannot. That one, yes. Okay. This example that we have example number 7, A, B, C. So I'm going to solve A for you, B will lived, C will lived, and I think that's all what we have. That's all we have. Example 8 also homework. So just remains one example for you with me. So pay attention. I'm going to give you this one. An example that I'm going to solve for you. Be sure you can check the Cal 2. The first lecture in the Cal 2 we need it. First lecture in the Cal 2. Beside it, of course, here during the exam you will find it. But also for Cal 2 you need it. So try to learn, to understand. Understood what I say? Like a page that I gave you, I see it's a key. This one is also a key. We solve that one. You know, sine of x dx is equal to what? Minus cosine x plus c. You are right. And we say that if this angle has derivative, we can solve it, right? So you see, if I, for example, 2x dx, I say is equal to what? Minus cosine 2x, right? Over 2, because we need the derivative. So I'm giving the generalization rule to not think more about that one. For example, when you saw something like that, when you saw sine alpha x, alpha is what? Any number, any constant. You are right, thank you. We can say is equal to what? We can say is equal to minus cosine alpha x plus c over alpha. Example, here's the example. If you have cosine, what do you say? Cosine alpha x dx. You can say is equal to sine alpha x over alpha. Understood? Example on it to understand, to memorize it, to be familiar for you. Cosine of 5x dx directly. Instead of saying 1 over 5 here or 5 to here, I'm going direct to solve it by alpha. When I say alpha rule, you'll remember. So I see is equal to sine 5x over 5 plus c. That's it. You got it? Hello? It's the first. 1, 2. Both of them, they are the same, so it's note number 1. Note number 2. Note number 2. If we have sine square of x, and I want to change it to cosine. So you saw this rule, right? Do you remember that? Do you remember that? How about cosine squared is equal to what? (2x). Understood? These are rules. If you forget it, here it's the first time. Okay? Even it's the first time for you, you can look at it. Any question about these rules? Identities, we call those identity. The name of this identity is half angle. Half angle. What do you mean by half angle? Why you say half angle? Look at here. Look at here. If you have 1, we have what here? 2. So here's half over here, right? If this, sorry. Okay. Hello. We have 2 here. If I have square, I have what? I have linear to power 1. For example, if I have cosine square 5x, tell me about, by this rule, I will get what? This one is fixed. So tell me about the cosine is equal to what? Yalla di. I'm a alpha. So 10. Am I right? Why? Because each number here, we are going to multiply by 2 in there. You got it? So tell me about that one, Jamaat. Day. Is equal to what? 1 minus cosine, okay? 2 by 2, 4x. You got it? So give me another example to deal with it. Is equal to what? X, just x. Just multiply this one by 2. Easy. So we have just cosine x because you multiplied by 2. Understood? Good. Now I'm going to solve that one. We say that integral of sine of x dx is easy cosine of x dx. Sorry. Am I right? Hello? Good. So how we solve that one? That's the question that you have. We cannot solve it directly because it's square, right? We cannot solve it. Why? Be careful. We have 2 here. Here is linear. Here is not. So how you solve? We are going to change to the linear one because in the linear we have a direct solution. When I say linear, it means x to power 1. So I'm going to change that one to what? Look at here, dear. I say is equal to integral 1 minus cosine A. Here's 1, so I have 2 over 2 dx. Am I right? And we can solve that one as 1 over 2 minus 1 over 2 cosine 2x dx. Again, am I right? Look at it, please. Why? Okay. So that one will be what? Hello? Integral Yokata-chan. Okay, next day, next lecture, I'll see you. I say, for example, Sama is equal to, you say no? Okay, forget about it. Because how many times we solved that one? The previous week and today, right? We say 1 over 2 to outside. Okay, it remains dx was equal to just x. Am I right? Good. How about that one? 1 over 2 outside. So how I solve that one? How we solve that one? By alpha. Use alpha rule. So I say is equal to minus 1 over 2. Solving that one is equal to sine 2x over 2 plus c. This is the alpha rule. Am I right? Okay. So we got 1 over 2x minus 1 over 4 sine 2x plus c. And here's the solution that you have. You got it? Good. So how you solve cosine, Jamaat? It's hard. No. The difference between this example, the difference between this example and the other is what? Just this plus and minus. You got it? So here we are, you get this thing. Now, can you solve this one for me? C. You see what? 1 minus what, Jamaat? 2 sine square, 2 sine square x, all of them sine 2x, I think. Yes, sine 2x dx. How we solve that one? Yalla. You need many things here. First, cosine square of x plus sine square of x is equal to what? Okay. Cosine square 2x is equal to what? Cosine square 2x. Or sorry. Just 2. Is equal to what? Cosine square x minus sine square x. I didn't yet. The second. The first. The second. The third. Sine 2x is equal to what? 2 sine x cosine x. You are right. Right? This all information needs to solve that one. How? Look at it. I'm going to change this one by that one. So I get what? I say cosine square x plus sine square x minus we have what? Instead of 1, I'm going to put cosine square of x plus sine square of x. Can I do like that? Hello? Can I do it? Two persons say yes. Can I do it? Yes. Good, thank you. So this is the one. And you have minus 2 sine square. So I'm going to write down minus 2 sine square x. And I'm close the brackets because we have like easy. You got it? And outside, forget about the outside. Outside you have what? Outside we have 2, I don't know, sine 2x dx. So sine 2x dx. Forget about it because I am not going to touch it now. Later I'm going to do this. So sine minus sine square plus 1 sine minus 2 sine. I'll get what? So it remains cosine square of x minus sine square of x, right? Yeah. And outside sine 2x dx. And sine cosine square minus sine square is equal to what? That one is equal to what? I gave you the second rule. Look at the second rule. Cos 2x, right? So I am changing that one into cosine 2x. And here we have sine 2x outside. Now it's easy. In the previous, if you are a headache, if you cannot solve, I say you are right. But for here, you can solve it. Wait. So how we solve that one? I have sine and cosine. Cosine or sine. So what's the problem? So equal to? You can see, you can use that one or that one. Second. I'm going to use that one. You can use the other one. I'm going to say sine 2x cosine 2x dx. In Kurdish, you have daskala. I don't know, something that you are going to use it every time you are using it, right? For example, like a measurement. You say, my foot is 1 meter, and you are using it. So this one, do like that. So how we solve that one? We solve many examples from like that. We say sine cosine is equal to that one is u, that one du. So, but I need what? No, derivative of sine is cosine. That's why actually, just we need 2. We need 2, so 1 over 2 outside. Yes? Derivative of sine, cosine. But derivative of here need what? 2. So we get 1 over 2 sine 2x what? Am I right? And you can put this one here. You got it? If you didn't understand the previous one, it's okay. The idea I plus, it's okay. But this one is easy for you. Careful. That one, we say that is easy for you. Careful. When I say careful, means that one of the questions will be in this form. So you should take care about it. That's all about the example. C, part C. I'm going to leave this one for you, it's easy. It's not hard, just look at it. Bring this one to up. Let me give you the clue. Example 8. We have what? Okay, 2z dz. 2z dz, okay. Here we have cubic root of what? Z square plus 1. You can bring this one to up. Here we are. So I'm going to write down like that. Careful. I'm doing quickly. 2z dz. And now you have u du. Okay, u du. So then you can solve it. Understood? Okay. So that's all about today. Here we are. Okay. Answer again. Okay. You can solve by another method, you know. Labati sine, you can, instead of using sine, you can use the cosine. Put the minus here and 2, minus 1 over 2, but in this time, in here, you will get what? You will get minus 1 over 2 cosine 2x squared over 2. Plus c, of course. You can use that one. Both of them are true. But usually I'm going to use the first sign because you have a derivative without any negative or minus value. That's why. You got it? Good for you. Now we stop here. Just let me read attendance. Okay, and we'll finish for here. Thank you for listening. Let me stop the video.